Okay, so what is asked is what is given is a rope coupling device where you have a pin which is joining basically these two rope. Okay, and we need to find out the maximum force that can be allowed in the rope without failing the pin. Okay, so first for this we need to first draw a free body diagram of the pin only, and then based on that we need to find out what kind of a force comes on the pin. Now this center part of the pin, the center part exerts a force. Now this P is getting applied by the right end of the rope on this section. Okay, this section of the pin supports the entire section supports a load P, whereas the left P is getting exerted on the pin at two places. Okay, and for without any loss of generality, I mean it has to be P by 2 and P by 2, right? So this region supports P by 2, this region supports P by 2, and this entire region supports P. So okay, so this entire P, I mean relative to this right hand, this I mean or the, for that matter related to the left hand, this the right hand tries to apply a load P such that the shearing occurs at this plane. Okay, so now what we need to think is uh, we need to find out, so the shear occurs at this plane, we need to find out the stress at this plane. So this plane, obviously if you take the top end, okay, the top end, I mean if you take a section here and if you consider only the top part, this is P by 2, and obviously the shear force here will be V, which is P by 2. So the V is the shear force, and the same thing, even if you take the bottom part and find out the shear force here, it will be V. Basically it's in double shear. Okay, so each area will contribute half the load. So the shear stress is basically at each of these location, at this or at this, the shear stress is V by area of each. So V is P by 2, half of the load is shared by each of the section by 2A, and this shear stress has to be less than 50 because it is again the material limit. Okay, so we need to find out, so P should be less than 50 MPa into 2 into area, which is circular cross section, so pi by 4, d square, which is 5 square. So P should be less than, in order that the stress is less than 50, the P should be less than or equal to 50 into 2 into pi by 4. So this value, if you calculate, it comes out to 1963.43 into 1. So the max value which you can have is 1963. Okay, so where is rounding off 1963 Newton. So that is the max value you can have, okay, without failing. So this is a shear stress, simple shear stress problem. Thank you. 1963 is the answer. Let me write here 1963 newtons. Thank you.